Hello everyone. In this video we will discuss about linear regression. We'll discuss about both simple linear regression and also multiple linear regression. So before we start, let's take a small example. Here we have a person called Raju and he would like to buy a house in a city which he has recently moved to. There are so many houses with different prices and he would like to know what is the price for the area which he is looking for. And he has collected some data, and the data shows a general trend, which is as the area increases, the price also increases. Even though the overall pattern looks linear, the points do not fall exactly on a straight line. For Raju to estimate the price of a house with a specific square footage, he can extend this trend line and make a prediction. But how do we find this best fit line when the points are not perfectly aligned? This is exactly what linear regression discusses about. It helps us compute a line that best fits the data even though there is an error or noise. So let us see how linear regression works. First, let us take some sample points. The x-axis indicates the area and the y-axis indicates the price, if we want to relate to the housing price prediction problem. And we would like to find the best line which can properly generalize this. And there are so many lines which we can choose. Let us see some sample lines. Suppose if you take a horizontal line, you can see the amount of error which it has. So the green points indicates the corresponding prediction point on the line, whereas the blue points are the actual ones. So if you choose a horizontal line, there is a lot of error between the predicted point and the actual point. So if we continue for all these, so if we some way try to compute the total error, which we will see shortly, we can say which of the lines can give the minimum error. Another line which is slightly inclined, here the error is still more as compared to the previous one. If we move in the other direction, we can clearly see that there is a slight reduction in the error. So which means that we need to know the slope and the intercept of the line so that we can find out the best line which can approximates the points which we have. So let us see how we can find the slope and the intercept of this line. So let us first denote with few notations. As you can see here, we have xi, yi is some sample point, which is, and xi and yi cap is the point on the line, and we don't know the w and b, where w is the slope and b is the intercept, which we would like to know so that which can make sense in some way. And so if we see the error, so the error is yi minus yi cap, and we want to minimize this error so that we can best get the best line. So the two stages which we discussed in the supervised learning, which is training and the testing. So in the training stage, we have both input and the output. Here the input is x and the output is y, but we don't know the model. The model is the line, and the model parameters are the slope and the intercept of the line. And we would like to find the slope and intercept by minimizing the error between the actual point and the predicted point, which is given here. We are trying to sum up. We are taking the difference between the y coordinates, yi minus yi cap, and we are trying to square it. So that if there is any negative errors, they don't actually get cancelled out. Instead of that, we want to make them positive, and that can be done in using two ways. One is taking absolute, and also by using squared. But square is a convex function, and the absolute function is not differentiable at x equal to 0. So therefore we square it to make it positive and compute the total error. So once we obtain the equation of the line by obtaining the parameters w and b, we can predict the housing prices for any unknown room sizes in the case of housing price prediction problem. The same can be extended for multiple linear regression where our independent variables are more than one. In such cases, we will be trying to predict a best hyperplane instead of a line. So we'll be having more than one independent variables, like in the case of housing price prediction problem. Apart from room size, we will be also having location, floor number, and so on, like age of house. All these factors are going to determine the price of the house. So there will be multiple independent variables and one dependent variable, and this is the model equation which is given here. Y is equal to w1x1 plus and so on wmxm and b. There are m factors which are influencing the price which is given by y. So these m features are given by x1, x2 and so on xm. So we get the n samples for multiple linear regression of n samples, and we then try to compute the model parameters w1, w2 and so on wm and b. So we will be seeing in the next video how to compute these parameters, which are w and b in the case of simple linear regression, and w1, w2 and so on wm comma b in the case of multiple linear regression. We'll see the complete derivation and also an example in the next video.